Hello friends, this is Jim with Science Talk. In this video I wish to share with you some news involving permafrost. Now permafrost is defined as ground that is permanently frozen for all the year or a good portion of the year. Sometimes there is a seasonal thaw layer, typically for a month or two in the summertime, where the upper 10, 20, maybe 30 centimeters will thaw out, but then it refreezes with the advent of wintertime. So what's going on here? And this is, if you were to ask climate scientists, what is it that they're really concerned about that gives them angst, if you will, it's the methane question. Now the IPCC in their reports usually do not mention too much about methane. If they do, it is not done in any great detail. They focus typically on carbon dioxide and other things going on. But methane is actually a more potent greenhouse gas. So what we're finding now is that the methane from when the permafrost thaws is much more than previously thought. Now it is more precise to refer to the methane as thawing, not melting. Melting is basically a change of state. Ice going from the solid to the liquid. That's a change of state. That's melting. Permafrost thawing is another thing, because as the permafrost thaws, what happens basically? Any vegetative material in the ground may start decomposing thanks to bacterial action, where methane is released. So, this is a report I wish to share with you. Methane emissions are a source of a greenhouse gas, obviously. And as I just said, this is what causes climatologists many sleepless nights. Methane is approximated to be about at least 30 times more powerful than carbon dioxide at warming the earth. In other words, at trapping in the heat. Sunlight comes in the short wave, it's reflected back out in the long wave. So the methane is more potent, more efficient, if you will, at trapping the long wave radiation, in the infrared end. So when we have the permafrost thawing, it's going to produce a lot more methane than was currently thought. So, in a study headed by Christian Knobloch of the Center for Earth System Research and Sustainability at the University of Hamburg, Germany, they published a study in the journal Nature Climate Change, where they're trying to improve the modeling and be able to make better predictions of how much of methane is going to be released from the Arctic permafrost. Methane and carbon dioxide are both produced in the thawing permafrost due to decomposition of organic material, animals, plants, what have you. Methane is produced when there's no oxygen present. Until now, scientists had always thought that more greenhouse gases were formed when the ground was dry and well aerated. In other words, oxygen was available. So what Dr. Knobloch and his colleagues have shown is that water-saturated permafrost soils without oxygen can be at least twice as harmful to the climate as dry soils. In other words, methane has been the role of methane has been underestimated. So what they've done is they measured for the first time in the laboratory the long-term production of methane in thawing permafrost. Basically, they took a whole pile of samples of 40,000-year-old samples from the Siberian Arctic, and they waited 3 years in a laboratory for it to produce methane. They observed the permafrost for a total of 7 years and found that without oxygen, equal amounts of methane and CO2 were produced. Let me state that again. Without oxygen, equal amounts of CO2, carbon dioxide, and methane, CH4, were produced. A co-author of the report, Susanne Liebner, from the Helmholtz Center, Potsdam, German Research Center for Geosciences, said, and I quote, "By combining process-based and molecular microbiological methods, our study shows for the first time that the methane-forming microorganisms in the thawing permafrost have significant influence on the greenhouse gas budget." New data was used by this team to improve a computer model. This is an ongoing process in research. You get more data, you're able to improve the modeling to get better predictions. That should not come as a surprise. And basically, they looked, the model was looking at how much greenhouse gas will be produced by the permafrost in the long term as it thaws, and they were able to put forth a forecast. The permafrost soils of Northern Europe, Northern Asia, and North America, they say, could produce up to 1 gigaton. That's 1 billion tons. A gigaton is a billion. So it's 1 billion tons. 1 gigaton of methane and 37 gigatons of carbon dioxide by 2100. Now, other questions that abound is how deep will the soil actually thaw out over the course of the next several decades and up until the 22nd century? Will this soil be wet or dry? This is what research is about. Research will try and ascertain those questions. So now, but here's the other thing that goes on. A positive feedback loop is set up. I know I've discussed this before, but it's worth repeating. You thaw the ground, methane is released. Methane traps heat, makes the air warmer, further thawing the ground, further releasing methane, further warming the air, further thawing the ground, further releasing methane, etc. That's what's meant by a positive feedback loop. Not that it's good, but that it exacerbates the situation. Positive feedback loops exacerbate the situation, sometimes to a runaway condition or situation. Negative feedback loops are corrective in nature. A little overshoot, corrective measures prevents it from getting too out of hand. So typically with negative feedback loop system, you have an oscillation around some sort of mean value or mean standard. So that's another issue. Now we have already seen the methane hydrates, which are basically water and methane frozen together as a conglomerate. We've already seen that. We get these methane hydrates on the floor of the Arctic Ocean. We're seeing those starting to not become solid, let's put it that way. We're seeing the bubbling of the methane to the surface. And teams from Norway have been documenting this amazing amount of outgassing of this methane from oceanic floors as well as from lakes. So that is a whole nother amount of methane being added. What really concerns scientists is how much methane is, what's the potential storage amount of methane that could be released into the atmosphere. And more importantly, what is the rate at which this methane will be released? If it's released at a slow rate, then this might buy humanity some time, if it got its act together, to install corrective measures and policies and change how we run our society, i.e. using renewable energy sources. If it happens very quickly, there could be serious consequences, not just for human civilization, but for aerobic organisms. So basically, the sort of dry humor is that, will the earth fart or burp? Depending which end you want to look at it from. Now, I want to mention two scientists who have done outstanding, stellar work on addressing the methane and permafrost question. Igor Semeletov and his wife Natalia from the International Arctic Research Center located at the University of Alaska Fairbanks have been going around the circumpolar north taking measurements and samples and so on, and they've just been doing outstanding work on addressing this question. So I wanted to mention them specifically because they're kind of leading the charge on trying to ascertain how much is there and what's the rate that's happening. So I wanted to bring you this report, and all I can say is stay tuned. I follow and track these stories as the new research becomes available. Please share this video. Please subscribe. Hit the bell so you know when I drop a video. Please support my work by becoming a patron at patreon.com/Science Talk with Jim Massa. I should also mention that I am Steemit. I'm steaming it now. But you can find me on Steemit, also Science Talk with Jim Massa. Thank you for your time.